Okay, so today we'll see about the error analysis. So what would be our resultant error if we have errors in our components? Okay, now what it says. Let us go through a few of the rules that how we gonna calculate the equivalent error for our result, right? Now, see there if there are two quantities A and B, and we have error in A as delta A and error in B as delta B. These are, we are representing A plus delta A. This is the specific quantity, okay? A plus or minus. Similarly, B plus or minus delta B. Okay, so this is how we generally present a physical quantity with error. So how gonna we calculate for the operations like summation, addition, multiplication, many more? Those are present in our uh, physical quantities, right? So let's see for the addition and subtraction in this. So whatever the error is, we are having, let's say delta A for A and delta B for B, quantity B, right? Now the error, total error would be addition sum of these two errors. If we are simply multiplying, sorry, simply uh, adding or subtracting the uh, quantities, right? So in this, let's say x as a quantity, that is a plus represented as a plus or minus b. It could be a plus b or a minus b, right? Now what would be the net error that will come if we have errors in A and B as delta A and delta B respectively? What would be the cumulative error? So for delta x would be delta A plus delta B. Notice that there is no minus sign here. Even if our x is represented as A minus B, we have the cumulative error as delta A plus delta B. Notice this point needs to be specified here, right? Now we'll see for the other formulations how we're gonna perform the error calculations there. Now coming to the multiplication and division. For multiplication and division, we implement the percentage of errors, right? Percentage of errors, like, so if we have a quantity as y or x is equal to a into b or a by b, so how, and the respective errors in A as delta A and B as delta B. Now what could be the cumulative error in the physical quantity, right? Now for this, delta Y would be delta A plus, sorry, delta A by A into 100% plus delta B by B into 100%. So this would be the net percentage of error in this, right? Now whatever the case is, if we are moving towards multiplication, division apart from subtraction and addition, then this would be the case of calculating the errors. So these two were the rules, two are the rules by which we're gonna calculate the errors in our physical quantity, right? Now we'll look into an example here. So yeah, so we are been provided with two resistors R1 and R2. This R1 and R2 with small errors in this measuring device, so are connected in series. Okay, now find the equivalent resistance for series. What is the formula for equivalent resistance? Sorry, I have mentioned delta. Yes. Yes, for R equivalent, as we all know, in a series connection R1 plus R2. So in this, our basic quantity would be, okay, in this, let's say R1 is 100 plus or minus 3, and yes, R2 is 200 plus or minus 4, right? Now, these are the small errors. Our basic quantity is this. This is confirmed that yes, we'll get our value of resistance around 100. So we'll simply add these two basic quantities. It is 300 ohm. Now, for simply addition, we'll do the net error would be delta R1 plus delta R2, that is 3 plus 4, it is 7. So we'll having plus or minus 7 in the final quantity. So R equivalent with error would be 300 plus or minus 7 ohm. Okay, great. Now for the next question here, let's solve this. Okay, we have a capacitor of capacitance C is equal to 2.0 plus or minus 0.1 microfarad, right? Now again we are with the voltage of 20 plus or minus 0.2 volt. Now what will be the charge Q? So for Q we have a formula CV. So this is case of the multiplication. So for multiplication, what is our net error is to like how we gonna calculate it. Net error is delta A by A into 100 plus delta B by B into 100. This will come in percentage, right? Yeah. Now what is this? Let's see here. Yes. This is A, this is delta A. Now this is in voltage V, and this is our small error, that is delta V. So in this the calculation will be very simple. So let me calculate first the error. Delta A 0.1 by 2 into 100 plus this is delta B is our 0.2 by 20. Now this gonna be 55, so 5% is gonna be plus this is, sorry, into 100, right? 5, so this is 1%. So our percentage of error is 6% of the actual quantity. Actual quantity, right? That is Q is equal to CV. Now what is our actual quantity here? Yeah, we can achieve that by our simple formulation of Q is CV. So these are the basic quantities. So what is that? 2 microfarad into 20 volt. Okay, now it is 40 coulomb. So 6% of 40 coulomb would be, that is our 0.06 into 40, right? That is 6, 2.4 coulomb. Now this would be 40 plus or minus 2.4 coulomb. Okay, this is our answer. Now for this multiplication and division, we need to take care of a little bit. How we gonna proceed? We need to proceed through percentage. I hope this thing is clear to all of you. So we'll see in the next videos for next applications of okay.